Hello there, my name is Matt Grimshaw. I am the founder and architect of apptheneum, a brand new science content discovery engine, and I'm here today to talk to you about content mobility in science. Now, please bear in mind that this presentation was originally a live presentation, and I'm recording this at the behest of several friends who would like to show it to other colleagues. So there are going to be some ums and ahs because this is very unscripted. But let's get going. So, first question is, what is content mobility? Well, I define content mobility as the ability for science content to cross disciplines, to go from one field of science to the other. And this is currently almost impossible due to the gravitational model, which is how science media currently organizes its content. And it's a very literal metaphor. You see, all science media, it doesn't matter if it's a website, magazine, or even technical conferences to a certain degree, all use the same concept. Firstly, create a theme or topic as your center of gravity, such as medical science here, and then let content and users gravitate towards that. And it's a fabulous model because it's been working for hundreds and hundreds of years, which has enabled mankind to create a complete planetary ecosystem of content. The problem and the issue we have with this is that the gravitational model traps that content and stops it from going elsewhere. It traps it in artificial orbits around these themes and stops it from migrating to other sciences. And it's a problem because science itself isn't organized that way. So why do we use the gravitational model at all? Well, as with most things in human civilization, it's a product of evolution. You see, the gravitational model itself evolved when science communication was extremely analog. How analog? Try 1665, because that's the year the world's first science journal was published. It was called Philosophical Transactions, and it was published by the Royal Society of London, and it had within its pages the entirety of human scientific understanding, which, as you can imagine, was pretty limited because it took 220 years for it to get big enough to need to split. So in 1886, Philosophical Transactions became Part A and Part B, the first covering the physical sciences and the second covering the life sciences, a sort of content mitosis, if you will. And this set the trend for all publications that were to follow. Now, if you extrapolate out from 1886 till today, you'll see that we have tens of thousands of theme-based journals now, websites, journals, magazines, all over the place, covering ever more complicated branches and fields of science, niches, all the way down to nanometer levels of finite detail. And this is becoming a problem because all of these little niches stop content. They trap content and stop it going where it was needed. You see, in an analog world, the gravity model made complete sense. But with the internet in play, it doesn't make sense at all. Now, this is in relation also to the fact that in reality, science is completely interconnected. It's not broken up into chunks, which is how the science media operate. And to give you a sort of graphic representation of this, this image here is actually a screen grab of a 3D representative model showing how the sciences physically interact. And as you can see, it's a bit of a mess. It's a tangled web of interacting sciences and disciplines, and they're constantly evolving from one minute to the next. Now, as you can imagine, the planetary slash gravity model doesn't reflect this reality at all. Now, to our team here, this suggested we need a new way to organize science content, and it's this basis upon which we have built apptheneum in its entirety. So apptheneum is, at its raw base, a host website, not too dissimilar to something like YouTube, but instead of distributing the world's videos, we want to distribute the world's science content. But how do we do that? Well, apptheneum's content uses a different organizational key, not theme-based, but relevance-based. We generate a relevance score which allows content to be organized by its relevance to the readers themselves. Well, how do we do this? Well, it's quite simply, really. We have an algorithm which is called our relevance engine, which generates relevance by scanning content for keyword associations between A, the field of science, and B, every word within a piece of content. And using these contextual relationships, we pull out what we call a topic cloud. And it's this we use as the organizational key. Because Moving the organizational key from theme-based to relevance-based basically frees the content from its source discipline, allows it to migrate anywhere it might be interesting. But now we've freed it, we now have to have another way of organizing it. We need another way to enable users to find content, discover what's relevant to them. In essence, we need a discovery engine. Now, if you've not heard of discovery engines before, don't worry, the chances are you're using one. Ever hear of Pandora? Well, Pandora helps users discover new music based upon their existing preferences. So basically you go on, type in a song or an artist, and it creates a radio station of similar songs and similar artists, helping you discover them. Similarly, StumbleUpon uses social media concepts, as in they track everywhere you click, to help web users discover new websites that they might find interesting. And it's these 2 points of discovery that we've basically tied in to our own discovery engine, which we call MyPage. It's essentially a user configurable science content discovery engine. It's dead simple to use. You see, you come to the site, register, log in with your LinkedIn account or even your Facebook account, and then tell apptheneum what fields of science you would like to follow or what you like, and within those fields of science what topics you desire. And from this profile it basically creates a complete homepage just for you. So basically you have something that you can come, refer to, that helps you find new content from outside your fields of science without having to lift a finger. So this graphical representation shows you the ecosystem. Here we have all of the input mechanisms, so magazines, journals, websites, blogs, anyone really. They publish or republish their content to the website. If republishing, they use something called a canonical URL, which backtracks to their own website, and then apptheneum redistributes it to as many people as necessary. It doesn't matter how broad the topic, because we don't differentiate between the sciences. Now, using this sharing mechanism, this relevance engine, we should hopefully expand audiences for any piece of content tenfold, we hope. But in addition to that, everything on apptheneum is socially enabled, so it can be reshared on LinkedIn or Twitter or Facebook, which actually hopefully amplifies the model of content sharing. But let's put this into a more direct example so you can see how it can actually help people in their day-to-day. This is Bob. Bob is a semiconductor researcher, and Bob has a problem that he's been stuck on for a number of months. Now this is Sue. Sue's a biotechnologist from A, a different part of the world, and B, a completely different part of the scientific community. Now she had the same problem, believe it or not, and solved it from a different perspective, and so wrote a paper about the solution 6 months ago. Now the question is, why can't Bob find Sue? Here we go back to our gravitational model. It's because they actually inhabit completely different gravitational centers, and therefore their content is stuck to those centers and they can't find each other. You see, this is the problem with science communications. We travel the world going to numerous technical conferences, listening to lots and lots of speakers, quite often until we're blue in the face. But we're very rarely exposed to people outside of our peer group. So what say you? That's what Google is for, is it not? Well, yes, you could make that argument, but the problem with Google is it's now so large and science so complex that unless you know exactly what you're looking for, you tend to get a whole bunch of pages that are absolutely useless to you, which just basically frustrate you more. To add to this, sciences speak a completely different language from one another. Electronics, electrical engineering speaks one language, biology speaks something completely different. And even if they're the same sort of geographical language like English, you'll tend to find that 2 scientists speaking in the same room won't understand what each other are going on about, which is the source of much of the frustration out there. So let's add apptheneum into our Bob and Sue equation. Now Sue was clever enough to publish her content in an open access journal, meaning she keeps copyright, or rather there is no copyright. This allows it to be republished to apptheneum with a canonical URL. Now apptheneum is also a registered member of Bob, and Bob has told apptheneum that he's looking for this specific topic. So apptheneum redistributes the content back to Bob, therefore solving his problem. This is an effect we call content networking. Now, it's this central hub of content that pretty much is the reason for us being, or more specifically, the cross pollination of that content. Because if we can convince the world to use apptheneum, imagine what that will do for innovation. Imagine what exposing all of these fields of science to other fields of high tech science will do. It will reconnect the sciences, which we hope will massively reduce duplication of effort, and we can actually help classify new fields of science too, because every author can actually add topics to the topic cloud, which can be a new field of science. Therefore, adding classifications to science in real time. Never been possible before. Now, because we'll be using one site and we'll be actually sending content across disciplinary lines, we should be able to create the best trend analysis maps and content migration maps that the world's ever seen. And this is really what excites us here. Imagine what we'll be able to do when science is completely interconnected. We can actually track what science is doing. These are the cornerstones of why we built apptheneum, the world's first content networking platform specifically for the sciences, and we hope you'll come and join us. Wherever we're at the moment, we have all of these social media feeds which you can connect and come and talk to us on, or of course you can come to the website itself. But either way, thank you very much for your time, and we hope to see you on the site very soon.